Let us pray. Our Father in heaven, we thank you for the beautiful day that you have given us. Pray that you may be with us and that you may protect us, and that you may keep the lessons that we learn from this lesson. In Jesus' name I pray, amen.
Amen. Thank you. So I will mute everyone. Lefentse, you can unmute yourself.
Okay.
All right. Good afternoon, everyone. Good afternoon, my friends. Today we're going to be speaking to and also get a presentation from Auntie Lefentse. She's an aircraft engineer. She's the one who makes aeroplanes fly. I don't know how. So guys, we have to listen attentively and let's note down our questions, right? If you have a question, if you have a notepad, you can write it down or keep it somewhere. So you remember when you spoke about the brain, we spoke about that place to keep your questions, right? Yes. And then when she's done presenting, she will take questions from you and she will answer all of them, okay? All right, so let's listen attentively and enjoy the program. Auntie Lefentse. Oh, she's from Sentinels DHH, right?
Yes, I am.
She's from Sentinels DHH. So I hope we will be inspired. And those who want to be aircraft engineers may also get in touch with her, go and see her in Sentin and all those kinds of things, right? I hope she'll be willing to assist us and show us around. Okay, over to you, Auntie Lefentse.
Okay, thank you so much. Hi, everyone. So, my name is Auntie Lefentse, and I'm an aircraft maintenance engineer. But what I do is I specialize in non-destructive testing inspections. And I don't know if there's anyone who has heard about NDT, non-destructive testing inspection, or if there's anyone who has ever heard about aircraft maintenance engineers. Can anyone give me an answer, an idea of what it is, if anyone knows what it is? What's an aircraft maintenance engineer? Or what is an NDT, non-destructive testing inspector? Anyone? There's no one. Oh, there's Tandiswa there raising a hand. Can you please unmute Tandiswa? Is he answering? Is he trying to attempt to answer? Like I saw someone raising his hand. No. Fine, it's fine. You can just mute everyone. What's happening with the screen now? Okay, let's wait for the screen. Yeah, I think it looks fine, but there are lines there. I don't know what are those lines.
Maybe somebody is drawing on your screen.
Guys, please, let's not draw on the screen, please. If you are watching on a tablet or anything, don't touch the screen of the tablet, right? All right.
Okay. So now, when you look at an aircraft experiences a lot of turbulence in the air. So when it flies up there in the air, there is all sorts of temperatures happening, and also rain can affect it, and also lightnings can affect the structure of the aeroplane. So when that happens, we know that when you use something, it gets tired. Even us, when we work hard, we get tired and we need rest. That's why we have the Sabbath day. So, and also when you look at a car also, you drive a certain kilometers, and then when you reach a certain cycle of kilometers, they will tell you that the car needs to go for a service. So they need to check whether the car is still fine, nothing is broken, or there's nothing that can cause any accidents with the car. So same applies with the aeroplane. An aeroplane, when it takes off and touches down, taking off, touching down, what happens is it accumulates cycles, it accumulates kilometers. And then when it accumulates kilometers, it needs to come back for service, so that it can be checked whether it does not have cracks or it doesn't have problems, so that when people fly, they fly very safe. So where do I come in as an NDT, non-destructive testing inspector? So what I do is I look for defects. What are those defects? The defects might be cracks. The defect might be corrosion. Corrosion is due to water coming in contact with a metal, which create rust. They call it rust. And then when the aeroplane rusts or it develops cracks, the structure of the aeroplane becomes weak. And then when it becomes weak, it might actually break. So what I do is there's methods that I use to look for those cracks, for those things that are not visible to the eye. Sometimes an aircraft can be bumped somewhere when you are at the airport. So you have services like trucks that bring in food so that food can get into the aeroplane, and you've got services like your staircases, whereby after you are flying, when you get off, you disembark, you have to go down the stairs. So sometimes it happens that the aeroplane actually gets bumped by that, and then it might develop a crack that people don't see with the visible eye. So what I do, I come with my special equipment and I scan the aircraft and see whether it's still okay for it to fly. So the methods that I use, there are 6 of them. I'm going to show you the pictures, but before I show you the pictures, I just want to tell you what are those 6 methods. The first one is penetrant testing. The second one is magnetic particle inspection. I know these are bombastic words, but it's fine. I will take you through step by step what do they mean. And the third one is eddy current testing. The fourth one is ultrasonic testing. The fifth one is radiography testing. And the sixth one is thermography testing. Can we go to the next slide? So now, the reason we do NDT on an aircraft, the reason we perform non-destructive testings on the aircraft, number one is for safety. Remember that when an aeroplane flies up there in the air, there is no service station. It means that if it experiences a problem, it's gonna fall down. It's not like a car whereby if maybe you've got problems with your brakes, what will happen is you will stop and park it at a parking station. There up there in the sky, there's no parking station. So we have to make sure that this aircraft, before it can fly, it is safe it does not have defects, it does not have problems, so that when people fly, they have a safe flight. So it means that if I am not there to inspect this aircraft, it means that the pilot cannot actually have his aircraft and fly it. So without us as aircraft maintenance engineers, the pilot cannot have an aeroplane to fly with. So us, we have to go there with our tools and check whether if this aeroplane is safe for flight, so that the aeroplane does not have an accident. Can we go slide, please? So there's a structure of an aeroplane. There's a structure of an aeroplane, and when you look at the front of the aeroplane, it's just that I don't have my mouse with me, but I am not going to touch the screen because I can see that, oh yes, there at the front is a cockpit. That's a cockpit. That's where the pilots sit. That's where they fly the aircraft. And then let's go to the engines. There are the turbine engines. You see, those are turbine engines, and also those turbine engines are the one that actually helps the aeroplane to fly. What they do is they suck in the air, and then they in the engine there's a combustion that is happening, but I'm not going to dwell on that because I'm not a mechanic. But I'm just explaining that air comes into those blades of the engine, and then when the air comes out at the exhaust, it will create a power for an aircraft to go forward. So there at the engines, that's where our stress is. Stress means that that's where our pressure is. So the aircraft is likely to develop cracks there. When you go there to the wing, that's the wing of the aircraft there. The wing of the aircraft, that's where the fuel sits. And also the wing of the aircraft, you've got the winglets and you've got the ailerons. Those ailerons and flaps, they help the aeroplane to go up and down, up and down. And then when you go to the back of the aircraft, the radar there, the radar, it helps the aeroplane to go sideways like this, go sideways. And then also you've got the vertical stabilizer there at the back, yes, which helps the aeroplane with this movement, you know, a pitch movement, up and down, up and down. So as you can see with the structure of the aeroplane, it's made up of aluminium, and it's made up of other materials like carbon fiber. It's made of materials like steel. So there at the radar there at the back, you see those black spots at the radar, the vertical stabilizer, and also at the wings. It's highlighted in black. The reason it's highlighted in black is because that material is different from the whole structure of the aircraft. Can you please mute people coming in? Can we please mute there's interference? Thank you. Yeah, so you see those black straps there. It means that the structure of the aircraft is not the same as the whole entire aircraft. So there you've got a fiber, a carbon fiber. So it means it's not a metal, but it's like a cardboard type of thing. So the reason I'm showing you this aircraft is because where I come in, I come with my special techniques to look for cracks in the whole entire aircraft. And there's method that I use to look for that. Let's go to the first method, number one. The first method is called fluorescent penetrant inspection. This is an example of something that is cracked. So how the fluorescent penetrant inspection work. Remember that I'm looking for cracks, and for defects that may cause the aeroplane to fall. So when you see there, it's a crack there. When you see the at A, it's a crack. So when it's cracked like that, what I do is I will perform a fluorescent penetrant inspection. What happened is, let's go to the next slide as I explain. So you see there, this is my workstation. It's not exactly like that, but this is my workstation. So fluorescent penetrant inspection involves this green thing. This green thing, it's like paint, né? But it's paint that can be washed away. So what happens is I will apply that paint on a material that I want to use. Let's say maybe with an engine, né? They will overhaul an engine and give me one of the components. As you see there at the bottom picture, those are links. They are called links. Ne? They are part of the engine components. So what I do is I will take those links, I will dip them inside that green thing, and then I'm gonna take them out. Or sometimes if it's a big component, I'm gonna spray them. You see that guy is spraying this paint on these components. So what I do is I will spray, or I will dip it in, and then I will wait for a few minutes of it to dwell on the material. And after that, I'm gonna wash away all the paint with water. And then after washing it with water, I'm gonna put it in an oven whereby it will dry. After drying, I'm gonna take it out of the oven. After taking it out, I'm gonna apply a spray called a developer. What is a developer? A developer, it's a brown, it's a white powder. I don't have it here on the picture, but can we go back to the previous slide so that I can explain the process? Yeah, so now when you look at B, ne, I've applied that green thing. After applying that green thing on B, you go to C. And then C, I'm washing it off with water. After washing it off with water, I put it in the oven so that it's dry. After it dries, then you go to D. D, that's where you're gonna apply a spray again, a white spray. So this white powder, what it does is it actually absorb the ink that got into the crack. The ink that got to the crack, and then I'm gonna view the crack with a UV lamp, a UV light, and then if there's any cracks, that green thing will come up and you will see there a crack. Let me show you how it looks. Let's go to the crack indication. So as you see there, you've got a UV lamp. That purple lamp, we use it to check the crack. So what happens is the crack will become visible. As you can see on the crack indication on the right in the picture, there is a crack there. And after I have found the crack, then I'm gonna write a report to say that this thing is cracked. It cannot go back to the aircraft. It needs to be fixed. So my job there is done. And when you look at the picture there with the person inspecting with the light, you can see that he is wearing gloves. He's wearing gloves and he's wearing glasses as well. And he's wearing PPE, personal protective equipment. That is an overall. You mustn't actually work with this thing with your own hands because it's a chemical. It can actually damage your hands. And yeah, you might react to it, but it's not a harmful chemical, it's a safe chemical. So this one is called liquid penetrant testing. Let's go to the second method. The second method, it's called magnetic particle inspection. These are very high words. So magnetic particle inspection means that I am looking for a crack, né? but I am using magnetism. I am using magnetic field to look for a problem. When you go to the next slide, I just want to show you the machine. How does it look so that I can explain the process. So now here is that guy standing there. What he's doing, he's performing magnetic particle inspection. So this guy, he's holding a hose that has got like a chemical coming out from it. So this chemical, it is made up of ion filings. And also that penetrant, they mixed it together. I think it's like paraffin, like it smells like paraffin. It's paraffin and ion filings. So there you can see there's a round big thing there. Please go to that round big thing there. Yes, that thing, it's a coil. A coil, what happens is you've got a lot of conductors. I don't know how to explain it like in simple ways, but that thing, it's used to generate magnetism to the part that we are testing. Ne? And yeah, let's just go to the previous slide and explain what happens. So there you've got you've got a an equipment that creates magnetic field into a material. So what we do is we apply current. We apply current to the material, and also that material that we are testing, it needs to be magnetic. It needs to be magnetic because we are working with magnetic field. You see there is a nut. There's a nut or a bolt. Go to the nut there. Yeah, the nut. So what happens is that machine, what it does, it passes current to the material, and then when it passes current into the material, it's going to create a magnetic field, and then that magnetic field will create an indication if there is a problem. If there is a crack, you see there's a North Pole and a South Pole. If there is a crack, then the ion filings, those green things up there, will just gather there, and then when you view under UV light, you will see that there is a crack there. And this one, we look for cracks that are subsurface. So they are not only on the surface of the material, but inside also. Yeah, those are cracks there. Those are visible cracks there. And after we do this, remember that we have magnetized the component, and it's full of magnetic fields. So what we do is, before it can go back to the aircraft, we will demagnetize it so that it doesn't affect the instrumentation of the aircraft. That is the second method. The third method, it's called eddy current testing. This one, I love eddy current testing because like you don't get dirty that much compared to the previous two methods. So what happened is, let's go to the next slide. So there, yeah, that's me there holding the eddy current machine. So can you see on the right? On the right, you've got this machine and you've got someone holding a probe. So that thing that the person is holding, it's a probe. It's called a probe. So what happened is that probe inside, it looks like, go to the previous slide, please. It looks like that. So what they did is they created a coil there. Can you please go to A, there, the coil, yes, that's the coil, that's the coil. So what happened is, because it's connected to the machine, so we need a voltage to create electricity coming into the coil. And then when it reaches the coil, it creates the magnetic fields. The magnetic fields are those blue things, going there. They are not visible to the eye, remember, just remember that they are not visible to the eye. You cannot see it, but I'm just showing you what happens when I use that probe. So that magnetic field, when it comes in contact with a conductive material, let's say that thing it's an aluminum plate, ne? When it comes in contact with an aluminum plate, what happens is it's gonna create eddy currents, and those eddy currents are in the red. Can you see the red there? Yeah. So they are circular. When they are circular like that, so it means that if there is a problem, there is a crack, those circular eddy currents will be disturbed. When they are disturbed, go to C. When they are disturbed, they're gonna create their magnetic field also, that yellow thing. So that magnetic field, the yellow one, will affect the blue magnetic field, and then you will have a crack. You will have something like this on the screen. Go to the next slide. Yes, that thing, that peep on the screen, that's a crack. But if a crack was not there, it was just gonna be a line. Go to that line on the side. Yeah, it was just gonna be a line on the side. So that's me there on the right-hand side. I'm performing eddy current testing. I think it was on an Airbus A340. Yeah, one of the Airbuses. So what I do is I will look for cracks there on the skin of the aircraft around the fuselage. This one, I like it because the results, you get them the same time. You don't have to wait for a long time. What you see is what you get. You can't even miss a crack with this one. And the fourth one, it's ultrasonic testing. This one, it's a bit complicated. So what is ultrasonic testing? So ultra means high, sonic means sound. So what we do is we are putting sound into the material and we are looking for cracks in it. So as you can see, we've got our transducer there. What is a transducer? So a transducer is something that converts one form of energy into another. So now we've got an electrical pulse from the machine. It will send a pulse, and then that pulse will go inside to the transducer. Please point there at the transducer. Yeah, it will go inside there, and then that thing, it has got a crystal which vibrates in and out like this. It goes like this. And then that thing, after what it does, it takes that signal and converts it into sound. That's why you've got sound waves. So waves are coming inside this material. So the first one there, you can see that the sound went down to the material and it went back to the transducer. And when you look at the scope there, it will tell you that that was an initial pulse. So what we are seeing is sound going to the end of the material without disturbance, and then coming up, and then on the scope it will show as like a peak. So that's the initial pulse. Now you are scanning, you are moving through your material. Then there you can see that there is a crack there. So where there is a crack, can you see that the distance that the sound traveled, it's shorter than the previous one? So meaning that the sound will come in and go back quickly because there's something that's blocking the way of the sound. And what you see on the screen of the scope, you will see a small peep like that. Yeah, that's a crack. So it means that it has traveled and hit the wall, not the wall, it has hit the crack before it can go to the wall. So that's why when it comes back, that crack signal, it's very short. Then when you go to the last one, it says back surface echo. So this is the sound that went through to the material and came back. So the back surface echo and the initial pulse will look similar, but the crack echo will indicate. So what happened is I would go to the aircraft and put my probe there. But now I cannot actually do this inspection without using a couplant. What is a couplant? A couplant is any liquid. So this ultrasonic works similar to the ultrasonic that that they do on pregnant women. Have you seen your mom when they are pregnant? They go for scans, you know. So they will put a gel on their tummy and they will put this thing and scan and scan and scan. So it's a similar process that happens here. So me, I'm a doctor for steel, for this aircraft, but they are doctors for human beings like myself and you. So what I will do is I will take that gel, put it on the aircraft, and then take the probe or the transducer and then scan to see if there's something inside that is wrong. And if there's anything that is wrong, then I will tell the mechanic to say that the structural worker that they need to solve the problem. So me, I don't fix things. I just look for problems and I tell them that, hey, there's a problem, they go and fix it. So this is the ultrasonic machine. This is the ultrasonic machine. As you can see there, go to the next slide, sorry. Yes, that's the equipment, that's the ultrasonic machine. But now this person, what he's doing, he's actually measuring the thickness of the material there. That thing there, it's called a step wedge. A step wedge is different thicknesses of materials. So the first one, it might be, can you please show them the step wedge? Yeah. So that step wedge, the first part might be 1 millimeter thick. The second one might be 2 millimeter thick. The third one might be 4 millimeter thick. So what ultrasonic testing does is we actually can measure how thick the material is. So what happens is an aircraft maybe will experience a lightning strike up there. Ne? Maybe it's flying and then there's like a rain coming on it and then the lightning strikes it. When it strikes it, ne, that material becomes hot. And then when it becomes hot, up there it's very cold. So it's hot and cold. So it changes the structure, or it changes the material of the aircraft and it becomes weak. So when it comes down, it lands. So what we do is the structural worker will go and inspect the lightning strike. After inspecting it, they will call me and say, come and check if there's a crack there. I will go there. And then when I see that there's a problem, what they will do is they will blend it. They will blend it. They will remove whatever crack that's there or maybe corrosion. And after removing it, I will come with this equipment and see if how many material was lost in that. Is it still safe for the aircraft to still fly with that material being eaten away? So this is ultrasonic. The fifth one, yeah, this one is the most complicated one. Not complicated per se, but it's dangerous. X-rays, radiography testing. X-rays are very dangerous. They can kill you, they can harm you. So before we operate these X-rays, what we do is we remove everyone from the hangars. The hangars are those big shacks, those big buildings whereby the aeroplane goes and parks inside. I didn't actually put an image for the thingy, for the hangars. So what happened is, can we go to the next slide before I explain the operation? What have I done before I explain how?
That means I can speak.
So yeah, so there it's an aircraft. Can you see there? It's a wing, not the wing. It's the stabilizer at the back. Yeah, that's the stabilizer. So what happened is, so because there's fuel sitting inside, I cannot see if there's crack inside that thing. So what I do is I will take a film like a cassette film, the films that they use, like when you do photography, they use those films. So even us in aviation, we have certain films that we use to take the image. So what we do is we will go inside the tank. We'll go inside the tank of the aircraft, and then we're gonna put the films inside there. when we put the films inside there, you see that machine, that green machine, show, please show them. Yeah, there. That's where the radiation comes from. So what we do is we make sure that there is no one there. Can you see that person there? He's busy setting up something. He's not supposed to be there. So us, what we do, we extend the cords so far so that we are not in the vicinity of the place. Then what we do is we set everything from the controller unit, and then we put our voltage, we put our current inside that machine at the time that we want the X-rays to go on the wing of the aircraft. And then after that, we're gonna start the radiation. When we start the radiation, then it's gonna radiate the place where we want to do the inspection on. And then thereafter, when it's done, we switch off the radiation, we come, and then we take the film, we go to the dark room where we process the film. And then after processing it, if there's any problems, when you see on the crack indication there, that's a film. That's a film, and then it will show that we've got a crack there. As you can see, that's a weld plate. That's a welded plate. Let's go to the previous thingy, scan. Yeah, so when you see on the right, on the right there's the X-ray source. That's no, on the left, sorry, on the left. On the left, the X-ray source, that's the source, that's the camera. And then here it's the welded plate. That's the weld plate. And then our film, X-ray film, will be underneath the specimen that we are checking. So what happened is we will radiate it, and then after it will come out as an image like that on the next slide, crack indication. The next slide. Yeah, is a crack indication. So let's go back to how the radiography works. So this is a tube, ne? This is an X-ray tube. An X-ray tube, it's at the, like, inside the camera. It's inside the camera. So what happened is we apply voltage. Ne? When we apply voltage, electrons, they flow inside from the negative side. Show them that negative side. Yeah, so electrons will be pushed in there, and then as they are pushed at a very high speed, at like 1,000 electron volts up, just passing through, and they are going to the cathode, to the anode. Actually, anode is a copper. This is a copper anode. The reason they are using copper is because it's conductive. So we want as much as electrons to be directed to that copper, so that you can have more radiation. So now there at the copper anode, you've got a thing called tungsten target. So that target, it's there to deflect the electrons at a certain angle so that you can have your X-rays. So when they are deflected at an angle like that, it gets hot there inside. So that's why we use tungsten, so that it doesn't melt the copper, it doesn't melt the X-ray tube. So the tungsten will deflect those electrons, and then the X-rays will be generated. And yeah, we can use those to look for defects that we can't see inside. So meaning that I can't see what's happening inside the steel. So this one, it works for very thick components, compared to ultrasonic and radiography testing. And the last one, it's thermography testing. So thermography testing, thermo means heat, and graphy means photo. So you've got heat that you are applying, and you've got a camera that actually looks into the material that you are testing. When you look there, they say, okay, let's go to the next slide. I think it's much easier to use the next slide. So the next slide, as you can see there, it's a setup for thermography. You've got an aircraft fuselage. An aircraft fuselage is the body of the aircraft. There you've got a heat source. A heat source can be a heat gun. You see there is like hot air coming out.
They don't want you to draw.
There's hot air coming out there. And at the same time, when hot air is coming out, what we are doing is we are heating the surface and then at the same time viewing it with a camera. Can you see there's a camera there? Infrared camera next to it. Yeah, infrared camera. So how the infrared thermography testing works. So remember I showed you at the back that there is what is called the radar. The radar is made up of carbon fiber, which is a honeycomb. They call it honeycomb because it looks like your honey things. So there at the right, that's the honeycomb. That's the thing that the radar is made up of. Ne? So what happened is when the aircraft goes up, because up there it's freezing, and then down here it's hot. So it's hot and cold, hot and cold, hot and cold. Precipitation, not precipitation actually. So what happens is the hot and the cold creates water to be present inside those honeycomb structure. And then when there's water inside, now there's a problem, because remember that the radar helps the aircraft to go sideways. So if now there's water inside that radar, when it goes high, because it's freezing up there, it might freeze, and then when it's time for it to change side, it might not be able to change because it's frozen. So what we do is with infrared thermography, we are looking for water inside the structure. And then if there is water present, you will see that on the next picture there, you can see that we have heated that honeycomb structure. And then when we heat it, because there is water, the water will take longer to heat up. Ne? And then when it's heated up, it will take longer to cool down. So the material takes quick to heat and cool down. So now this material, we heated it and now it's cooling down. When it has cooled down to its normal temperature, you are left with those black spots there. So meaning that there's a problem there, there's water there. So that's how we look for problems in the radar using this machine. So this is the camera that I use. Next page. Next slide, please. Yeah, so this is the infrared camera that I use. It works on the basis of checking the temperature differences. So if something is too hot compared to what it's supposed to be, we'll know that no, there is a problem there. And if it's too cold also, we can also see if there's a problem. So in a nutshell, this is what we use to actually look for problems. We are looking for these problems because we want to save people's lives, and we want to make sure that everything is safe, it's defect free, so that people can have a safe flight, so that even the pilot, when he flies his aircraft, he feels comfortable to say that this is serviceable, this is good, it's in a good condition, I can fly it. And what I do is I just look for those problems and I just report those problems, and I just save people's lives, because I believe that what I do is very critical. Because remember, if I miss a crack, the aircraft is gonna fly up there and then it's gonna crash, because the crack will a small thing can actually expand to be a big thing, because there's high turbulence up there and there's pressures and there's all sorts of things. So I'm hoping that I've done justice in trying to explain the complexity of what I do. So in a nutshell, in conclusion, NDT is very critical. It's very critical in the aerospace industry, and because now we are going for fiber aeroplanes, we are doing away with steel. So we're gonna do a lot of inspections such as this thermography and ultrasonic on the aircraft. So in a nutshell, yeah, that is what I do. Non-destructive testing. You are testing something without destroying it, because we want to use that thing after we have actually tested it. And yeah, that's it. God bless. I hope that I've done justice, you know, and yeah, I'm ready for questions now.
It's like you're speaking like you ate your lunch. You don't sound hungry at all.
Wow.
Musa, you can take over. Is Musa here?
Also, can I say something? Can I say something really interesting? So, because this NDT, like, it's not known out there in the whole world. So if you want to actually consider a career, I would say that, especially to the ladies, become an NDT inspector. So now currently, we only have 2 level 3s in South Africa that are qualified to be level 3s in aviation. So for me, I'm level 2. I'm level 2. So I'm planning to go to level 3 so that I can become, you know, like a level 3 inspector and break the record, you know. And last year actually, you know, I've been awarded that I'm the first female inspector to be in NDT, to show how complex it is, that women don't know a lot about it. You know, it's considered to be a male-dominant place. But here I am. I'm the only one, and I've done it. So I'm encouraging you, young ones, to Google it and read about it. You can work anywhere. You can work anywhere. You can work in aerospace. You can work in construction. You can work in industrial, anywhere. Because remember, when things are in service, they develop cracks. So they need us to tell them that, is this machine still fine to use, or is this thing still okay to be used? So NDT is very, very crucial in all the industries.
Okay, Musa, I see you are back. You can take over.
Where are you planting? Take note of what happens here.
Musa. Where's Musa? Okay, so thank you very much, Auntie Lefentse. Thank you so much for your presentation. And maybe Daniel, may you help us just stop screen sharing so that I can see everyone on my screen.
Okay.
Guys, what do you say to the presentation? Was it helpful? Are you happy?
Yes.
Yes. Okay, any questions?
Yes.
Yes.
Yes. Who has a question? I can't see anyone stand up.
I know, like NDT, it's like it's something new, like it's new to the mind. Even myself, how I got to know about it was that I was at varsity and I had applied for chemical engineering. When I got there, okay, I did the enrollment and everything. So now when I had to go take my subject from the HOD was like, no, the course is full. But what you can do is you can do NDT, because the first semester subjects are the same, and then you can convert to your chemical engineering. God works in mysterious ways. Imagine if had I continued with chemical, would I have been famous today? I don't think so. Today I am famous because I'm a first NDT inspector.
You won't be even
SA.
on this platform.
I
We're not going to
know.
invite.
Like, as soon as I knew about it, I was like, no. I think this is good. Like, I'm gonna carry on doing it, and yeah, and I thank God for that. And
so, what subjects do you need to do at school to qualify for that course at university?
maths and science, maths, science, English. So what happened is VUT is the only institution that does it, but you've got actually NDT schools around that gives the course. And like after grade 12, you can actually go do NDT in those institutions, do your level 1, level 2. So what happened is the exam that I write, it's similar the whole world, you know. So meaning that if I get level 1, I get level 2, I can work anywhere because they recognize the certificate that I have. So you don't have to go to VUT. For me, like I was fortunate to go to VUT. It has really actually expanded my mind, and also my diploma is going to help me with if ever I want to do managerial positions or whatever, and also with my level 3. Because as a level 3, I'm an overseer of all the level 1 and level 2. So I'm the one who will create procedures, will come up with resolutions if maybe they are failing to use a certain method and they are struggling. So that's my aim, to actually become a level 3. And yeah, I like with God's help, you know, and me pushing, I believe that I will be the first female in South Africa to be a level 3. So that's where I'm heading to.
Yeah, you're heading there. All right, Trump and Danielle, you had a hand up. Well, is your hand still up, or you're not asking anymore?
It's tough. NDT guys, I know it's tough. I know, and I understand. Maybe what I should have done, I should have just introduced only one method so that I don't confuse. You know.
No,
So next time, what I will do is maybe you can bring me back and I discuss in detail one method, how it works, and then the operation of it and everything, instead of just, you know,
Team Lanjan, you've got a question.
Lanjan, you got a question, yes.
My question is, how long does it take to repair the airplane or something? Or the thing
Okay, so what happened is, so remember the aeroplane is big, ne? It has got a lot of compartments. So meaning that I can't work alone on it. There's a lot of people working on it. You've got your mechanicals, your mechanics, you've got your electricians, you've got your structural workers. So what happened is an aircraft will be scheduled for a C check or A check or D check, ne? And A check means that it's a minor check, so it's gonna take like a day or a few hours. And then a C check, normally it takes like 3 months, depending on the availability of spares as well. So, and the D check might even take longer. So what happened is with an A check, it's only like few things that you check, maybe your oils, your whatever. But C check, what we do is we remove everything, we overhaul it. Then it becomes an empty tin. It becomes an empty tin, and then we come, we do the inspections, we do everything, and then they come back again and they put things together and they repaint it again, and then it's serviceable. So that might take like maybe 3 months, 4 months, or 6 months, depending on the findings. Cause sometimes I can find a crack. When I find a crack there, then it means that the check will be extended longer, because now they need to repair that problem.
Makotore, Tadiwa Makotore.
Do pilots get fired from not checking if there's holes?
Okay, so remember pilots, ne? That's a good question. Remember that pilots, what they do is they fly the aeroplane. So we as engineers, we are the one that fix the aeroplane. So what happened is before the pilot can fly his aircraft, what he will do is he will have a list of things to check whether this was done, and everything. And when everything was done, then he can fly the aircraft. But now, if me, I have done a job, ne? But I didn't, like maybe I've missed a crack, ne? I've missed a crack, and then it happens that that crack creates an aeroplane to crash. When it crashes, they're gonna do an investigation. I don't know if you guys have watched aircraft investigations. So what they do is they will assign, they will assign a team of people, of inspectors and engineers to actually to look where the fault was. Because I worked somewhere and I signed to say that I did not find any crack. Ganti, in turn, the crack was there. So what they will do is they will check and troubleshoot and get to the root of the problem. When they got to the root of the problem and they see that no, an entity person was here, but they did not see the problem, I actually can go to jail. Like I can be arrested, I can be fired. So whatever that I need to do, it needs to be right. I need to make sure that whatever decision that I have made, whether this thing is serviceable or not, it needs to be accurate. Because if I am not accurate and then the airplane crashes, I'm in big trouble. They can fire me.
So when aeroplanes crash, so is it only caused by the cracks or it's caused by something else?
You're muted, Lefentse, you're muted.
Oh, sorry. So it can be caused by many things. Remember that we are humans, ne? There is what we call human error. So sometimes it might be caused by a mechanical failure. Mechanical failure whereby the pilot is trying to move something and then it's not working, and then it's, you know, so like it's not only due to cracks, but also to human error. Maybe the pilot, or maybe like a component is not functioning. There's instances whereby, like as I'm watching the aircraft investigation, that there's a certain equipment that is not working, whereby like that thing will tell you that how high you are or how low you are. So sometimes if that thing is not working properly, it will send you wrong messages, and you will think that your aeroplane is actually high where else it's low, and that can cause a crash. So anything can cause a crash.
Okay, Renee, and then Palzo will come after that, and then Galaxy J7 Prime. Renee, you may ask your question.
What if there's a crack during the flight? Is there a team that is on board the plane?
Okay, so it's done. Okay, so what happened is when an aeroplane flies, inside you've got the first officer, you've got the captain, and you've got the flight engineer. The flight engineer normally is the mechanic. So let's say maybe like there is a crack somewhere. They won't see it, of course, because the system is not telling them that there's a crack somewhere. But what happened is maybe there is a crack. So when it lands, maybe at a different destination. So what the flight engine, what the mechanic would do is they would do a walk around the aeroplane to see for obvious things, for obvious problems, obvious cracks on the aeroplane. And then if they find that there is a crack there, then they're gonna snag it into the logbook. So an aeroplane has got a logbook whereby you put everything that happens to the aeroplane. So they'll say that, okay, we have found a crack at the fuselage. And then when they found that, when that aircraft comes back to the hangar, so they will call me to say that there was a snag. We call them snags. There was a snag that was snagged by the pilot or by the engineer. Please come check if this is a crack or not. And then I come and with my equipment and go there and see if is this a crack or is this not a crack. Then after then, yeah, I will tell them that, okay, this is a crack or it's not a crack.
But then does it land for you to get there?
Come again?
Does it land for you to get there?
Yes, like it has to land. Remember that I said that up there in the sky, the aeroplane cannot park anywhere, unfortunately. So if there's a problem up there, it must come down to earth, and then we check it if it's okay. It has to land.
Yeah.
All right. Who was the next one? I think I've lost my. Mpato Ronel, is your hand still up? Yes.
Yeah. My
Yes,
question was, do you have to check every time when the plane lands?
Yes, we have to check all the time because remember, as it took off, we don't know what happened there in the sky. So anything might have happened. Maybe it had a bed strike. A bed strike is when the bed in the air gets sucked inside the engine. So that can cause a damage to the engine of the aircraft. So we have to check it when it lands. Every time we have to do that because we don't know what is it that happened while it was still up there. So when it comes down, we have to check. But there's certain things that are scheduled for checking it when it lands.
Okay, Galaxy J7 Prime. Galaxy J7 Prime.
What does MDT stand for?
Oh, that's a good question. You see, these are the questions that I want about NDT. Yes. So NDT stands for non-destructive testing. So it means that you are testing something. Let's say that I'm testing an engine. So I am testing that engine without destroying it. So it means that after I test it, it still needs to function afterwards.
Okay, thank you.
Yay.
My question is, if you delay fixing the aircraft, do you get fired immediately or they give you a warning?
Okay, so what happens with an aircraft is, when it, like I explained with the car, when you drive a car, when it has reached a certain kilometers, you must take it for service, isn't it? So even with the aeroplane, what you have to do is after a certain cycle, a cycle means going up, touching down, one cycle, going up, touching down, take off, touchdown, one cycle, take off, touchdown. So when it has reached a certain cycle, that cycle comes with certain inspections. So those inspections have to be done, So sometimes when maybe when they are not done, those inspections, what happens is there is a body that looks over us. That body can fine us. They can fine us that we are not following according to the schedule. So if something is delayed, you can be held accountable for the delay, because that delay can cause the aircraft to be grounded. So meaning that it cannot fly because you delayed on doing a certain inspection. And then when that happens, you can, yes, get a warning, but like it's not a dismissal.
Then there is 110705. You can ask your question.
How does the engine work?
Wow. Wow, that's a big question, eh? I will try answering it. Remember, like I'm not a mechanic, you've got mechanics that work with engines only, who are specialists in engines. So how does an engine work? So an engine, it's made up of blades around. Those blades are shaped in a form of an aerofoil. Are shaped in an aerofoil. They are not straight, but they are like twisted like this. When they are twisted like this, their aim is to bring in, suck in air. When they suck in air in the engine, you've got different stages. So that air, what it does is it gets inside, and there's a combustion chamber whereby there's injectors that will take out fuel, and there's fire. There's burning of fuel and fire inside. And that burning of fire and fuel inside, what it does is it is taken to a last stage whereby when the air comes out, it comes out as hot and as like at a certain force, so that when it comes out, it just pushes the aeroplane forward. Yeah, that explanation, like it's not technical, but I'm trying to, make it simple for you to say that you need air coming inside, and then inside you've got pistons, but it's turbine, not piston. So you've got fuel coming in, and there's fire that sparks the thingy, the fuel, and then it creates heat, combustion inside, and then it gets pushed away outside, and then the aircraft can go forward.
Okay, Lesonte. Yeah, that was clear though. Well, at least to me. Lesonte, you can ask your question, then we go to Trump and Daniel and Galaxy J7. And Tina.
When the engine is broken, you can take it out.
Yes, you are right. When there's a problem in an engine, what we do is we would remove the whole engine. We remove it from the aircraft. We take it to the jet shop, to the engine shop. When it goes to the engine shop, they're gonna remove it, overhaul everything. Every single component is gonna be taken off, and then we're gonna check the whole component. And then after we check it, then we're gonna rebuild it again, bring everything together, and then put it back to the aircraft.
When the engine of what's gonna happen with the wing?
No, what's gonna happen with the wing?
Yes.
I guess when the air gets inside the engine and burns, what happens to it? You said it goes out and then it propels the aeroplane forward, right?
Yes.
So I think he's asking what happened.
Remember, the engine is mounted on the wing.
Oh, it says on the wind.
Yeah,
Wing.
it's still
Oh,
on the
wing.
wing.
Okay.
Yeah.
And then we have Tina.
Can a plane crash sometimes because of a pilot doing it on purpose?
No, remember that we are dealing with people's lives here, and our motto is safety is non-negotiable. So when we work on an aeroplane, we make sure that we don't do things that are bad on it purposely, because maybe sometimes your daddy might be flying on the aircraft, and you don't want that aeroplane to crash, isn't it? Because Daddy is inside there. So what we and the pilots do, we make sure that we do the right thing on the aircraft, even if when no one is watching, we have to do the right thing because people's lives are in our hands. So we don't purposely do bad things on the aircraft, but we do good things on the aircraft so that Daddy, Mommy, and yourself can fly safely and you feel safe in a good aeroplane.
But once when I was watching aircraft investigation, right, they saw that a pilot, when he was in the air, he pressed some switch when he was going to the toilet, but he did it on purpose, and in the end the plane crashed.
Really? That's interesting because remember, the aeroplane can fly on its own, isn't it? There's something that's called autopilot. So you can put everything inside to tell the aeroplane that this is the destination, this is how you're going to fly, this is the route you are taking. So an aeroplane can fly on its own. Yeah, so I don't know about that aircraft investigation, but like there are situations whereby you know how people can what you call this when you are held hostage, you know, like there are situations like that. I mean, when you look at that 9/11 thing that happened in America, so that was purposefully done. So, but we don't behave like that. When we go to work, we make a declaration to say that we will do right things on the aircraft.
Okay, thank
Trump, and Danielle.
Is it true, like when lightning strikes the plane, is the plane gonna be okay or it's gonna crash?
When the lightning strikes the aeroplane, is it gonna crack?
Crash.
It's not always the case. Hey, it's not always the case. Remember that the aeroplane is made so strong so that it can withhold all these problems. So yeah, like it can't crash from a lightning strike.
Okay, there's a question here. I heard that some aircraft engineers travel on flights. What can an aircraft engineer fix in the air? So why do you need an engineer inside the airplane?
Remember, there are systems. There are systems that they need to check. You know, like there might be mechanical faults happening, or there might be electrical faults happening. Remember, the pilot doesn't know much about mechanical engineering and electrical engineering. Maybe there might be a fault in a system whereby the fuel quantity indicator is not working. So now they need to troubleshoot to say that what's causing the fuel quantity indicator not to work in the cockpit. So they've got means and ways of putting data somewhere to check for, okay, if this thing is not working, like they can troubleshoot to go back to say that, okay, it might be this, it might be that, up until they get to the problem and they fix that problem.
Okay, nice. Galaxy J7 Prime, your hand is up. And then after that, I'm going to Mpatso.
My question is, how many years does it take to do the course?
Okay, so I did my 3 years at varsity, but when I came to SAA, I had to still undergo level 1 and level 2. So in a nutshell, it can take you, because you also need experience. So NDT, what happened is experience speaks a lot, because you can study theoretically this thing, but you really need to gain experience and hours so that they can award you a certification. So I can safely say 5 years for you to become a proper level 2. Plus minus 5
And
years.
my other question is, which one is better, a pilot or being an NDT?
Okay. So, what an interesting question, actually. You know what I think? Actually, not what I think. What I know is when you look at your body, you've got eyes, you've got nose, you've got lips, you've got arms. I can't say that eyes are more important than the mouth, or the leg is more important or better than the, like they all work in one accord to create one body. So a body cannot function on its own, but you need the brain, you need this, you need, so that's how we work. Pilots, they need us. They cannot fly the aircraft without us. That's all I can say. If there is no me, there's no flying.
Yeah, Mphatso.
My other question was, what makes the plane fly?
Okay, I guess this question is not an NDT question. Hey? It's not an NDT question. It's a theory of flight, and I've done theory of flight long ago. Okay, so what happens next? With the aeroplane, you've got the wings. When you look at the wings, I wish I could draw. Let me draw something for you so that I can explain it. So that it can become easy.
You can press share screen if you're using a phone, and then you can press whiteboard.
Okay. So is it visible? This is the wing of the aircraft. Can you see?
Yeah.
Can you see the shape it's like?
Yeah.
And then there's an arrow up there, arrow down there, arrow on the forward at the back. So what happened is, for an aeroplane to fly, all these forces must balance. The force from on top, at the bottom, at the sides. So meaning that when air comes here, so the pressure of the air from the top is gonna take longer to travel to the back. But when you look at the bottom, air will just come in faster. So meaning that when it comes faster here at the bottom, it's gonna create a lift. It's gonna push, and then this is gonna lift, and you've got like an aircraft going on top. I know my explanation is,
Yeah. Last week, Uncle Philip, the pilot, explained that. So it's still on the video. If you go to the YouTube channel, you can go over it. Mphatso, were you here last week, Mphatso?
No, I wasn't.
Okay, so there's a YouTube channel where we put all this material in. You can, I'll put my number there. You can WhatsApp me, and then I can send you the link. And then Hazel B, you have a question.
My question is, how much time does it take to build a fully working aircraft?
Yeah. That I'm not sure. Hey, that I'm not sure. Yeah. Those are aeronautical engineers that deal with that. I am not sure, but I think it takes a long time. I mean, when you look how they built a car, sometimes like it takes like a month or 2 months or whatever. You see, so I don't know. When it comes to Boeing and Airbus, how long does it take? I will have to go on the net and search how long does it take to manufacture? Because remember, I am not dealing with manufacturing, but I'm just involved in the maintenance side of things. But I can actually go back and see how long it takes for an aeroplane to be manufactured and come back to you.
Okay, we have a question here from Magabongwe.
What is the aeroplane made out of?
Okay, so an aeroplane is
Can I
made
answer
up
the
of
question?
aeroplane. Oh, you want to answer it? Someone wants to answer it.
It's made of aluminium.
Well
Aluminium.
done. Not only aluminium, ne? Like
Aluminium.
it's 70% aluminium, ne? Or 80%. And like I said, remember I spoke about the radar. It's made up of carbon fiber. Like it looks like a cardboard, but it's not a cardboard. It's not a metal also. And other parts also, they steel, and other alloys. Other alloys meaning that they took maybe two different metals, they melted them together, and then they produced a certain alloy. But aluminium.
Is it true that they use aluminium so that the airplane can fly because aluminium is very light?
It's very light. Well done. Yes, it is very light. That's why we are using aluminium. Steel is very heavy, and other metals are very heavy as well.
All right. It seems we don't have any more questions. Lefentse, you don't regret coming here, right?
I don't regret. I actually love you. I love this kids, but I feel that they are not asking a lot of questions about NDT, but which is understandable. What we can do is we can do it one day at a time, whereby I can present only one method, not many methods, because they are very complex. But one method, and I show them how it's done so that they can have a clear understanding.
Okay, I think we can take
another question.
with two hands
What
up,
is the
Tina and
difference?
Lael. All right, go
What
on,
is the
Tina.
difference?
Go on, Tina.
My question is, why do we need NDT besides the fixing of planes? If they weren't planes, we need NDT.
Why is it important to have NDT in aerospace? So why is it important? It's because an aircraft gets tired. When it gets tired, it can develop cracks, it can develop corrosion, a lot of things can happen. So you need me, because I need to make sure that this thing is safe. You don't want to fall from the sky. I make sure that it doesn't have problems. So I am there to make sure that the aeroplane is safe to fly from here to UK, or to fly from here to Brazil, or to fly from without experiencing any problems. So I make sure that it's safe, very safe, 100% safe.
I have another question.
What's your question?
Can an aircraft fly from here until can a plane fly from here until Washington DC?
Yes, it can. Yes, it can.
Yeah, you have planes that fly for 15 hours or more without stopping. For instance, from here to New York is minus 13, 14 hours non-stop. So you fly over the ocean. Is it from here, Botswana, and then over the ocean, and then you're in America after about 14, 15 hours? Galaxy J7 Prime.
My question is, since the material called black box does not crash, why can't they make the whole aeroplane out of black box?
You know why? You know why? Someone said that an aeroplane needs to be light for it to fly, isn't it? So if you're gonna make an aircraft steel, a heavy thing like the black block box material, it's not gonna take off. And then also remember that we need to reduce the cost of fuel. So if anything it's heavy, it's gonna eat a lot of fuel and you're gonna pay more money. So we are trying to do away with a lot of heavy materials. We need like very light materials like aluminium. So the black box is made up of a material that is very strong. Also, aluminium is still strong, but that material might be heavy for the aircraft to take off.
Thank you.
Excuse me,
Lael.
First question. Why did you make black boxes in the first place?
Come again?
Why did you make black boxes in the first place?
Remember to record everything. Remember that we need to record everything that's happening in case that if something wrong can go wrong, so that they can recall from the black box what went wrong, so that we can also fix the problem for future. Because sometimes it might be like a defect or a problem that was manufactured with it and they were not aware of it. But now when you have that black box, it will record everything that takes place. And if maybe an aeroplane crashes, then they will be able to take that data and see where did it go wrong, so that we can prevent more accidents and more incidences.
Okay, Lael. Lael, probably that's our last question, right? Yeah.
Yes.
What's your question?
How do the wings of the aircraft make the aircraft fly?
Okay, like I explained, the wing of the aircraft is made, this thing is not visible, like is made in a shape like an aerofoil, in an aerofoil. So that aerofoil, when air comes, when the wing is attacking the wind, so because it's shaped like an aerofoil, the pressure that goes on top of the wing causes the aircraft to lift. And the pressure that goes underneath the wing causes the aircraft to actually go up. So the two forces from the top and the bottom, because of the shape of the aerofoil, it makes it that it causes lift.
All right. Thank you so very much.